Welcome to the deep dive. Today, we're looking into something really central in AI right now, moving past just fluent language towards, well, actual reasoning.
That's right. It's a significant shift.
We've got a lot of research here that digs into how AI is starting to, think getting beyond simply recognizing patterns.
Absolutely. I mean, the progress in LLMs generating human-like text has been, frankly, stunning. But the real focus now, or a major focus anyway, is building models that can genuinely reason.
You mean like logical deduction, solving maths problems, understanding cause and effect, that sort of thing?
Exactly. And common sense inference, too. It's really about moving from those quick, almost intuitive responses to something more deliberate, more analytical.
Like the difference between a gut reaction and really thinking something through.
Precisely. That's a good way to put it.
Our sources bring up this system 1 versus system 2 idea quite a bit. How does that apply here, specifically with AI?
Yeah, it's really helpful framework, actually. System 1 is that fast, intuitive thinking pattern matching, quick associations. You could say a lot of standard LMs operate mainly there. They're great at predicting the next word, for instance.
Sure.
System 2, though, that's the slower, deliberate, analytical stuff. And that's what these reasoning models are being designed and trained for, to engage that more effortful kind of processing.
Which you absolutely need for complex problems, right? Where just matching patterns won't cut it.
Exactly.
So are we saying these are fundamentally different from just bigger language models? What's different in how they're built or trained?
Well, yes and no. They often use similar basic building blocks. The underlying architectures can be related, but the training methods are key. Reinforcement learning, RL, is a big one.
How does RL help with reasoning specifically?
Instead of just rewarding the model for the right final answer, you incentivize the quality and the logical steps it takes to get there.
I see. So the how matters as much as the what.
Precisely. Models like DeepSeek R1, which performs well in maths and coding, that's an example of this approach in action. And then there's post-training refinement, too.
What does that involve?
Techniques to make the reasoning more reliable, grounded in facts, maybe making sure the way it reasons aligns with how we expect it to. Distillation is also interesting.
Transferring capabilities from a huge model to a smaller one.
Exactly, making that reasoning power more efficient.
It feels like we're pushing these models towards a much wider range of tasks. The research mentions handling different kinds of data, text, code, math, images altogether. That sounds like a pretty big leap in understanding.
It really is. I think the ultimate goal is to get away from models that only understand one thing, like text, and move towards systems that have a more unified grasp of information. A bit more like how our brains integrate different inputs, perhaps.
Right, applying core reasoning across different data types.
Yeah, it needs a deeper level of abstraction.
But surely this extra processing, this deeper thinking, comes at a cost. There must be trade-offs.
Oh, definitely. Reasoning is computationally expensive. These models generally take longer to process things.
And cost more to run, presumably.
I've heard this term thinking tokens. That's right, more resources are consumed. It's that fundamental trade-off, speed versus analytical depth. You can't always have both, at least not yet.
And the research landscape is moving fast.
Incredibly fast. Places like ArcSIFs are just flooded with papers. Surveys trying to categorize all the different ways people are trying to boost reasoning, better prompting, new architectures, different learning approaches.
Specific areas getting attention.
Yeah, lots on post-training tweaks, like you mentioned. Also how things like chain of thought prompting work, especially with really long inputs, and these program-aided approaches where the AI uses external tools.
Okay, let's talk about prompting. The material really hammers home that just asking a simple question isn't enough anymore for these reasoning models.
Absolutely not. Prompt engineering becomes critical. You need incredibly clear instructions. You have to give it all the necessary context. Well, defining the problem precisely. All the background info, the data, any rules or constraints, and maybe even what success looks like for the task.
There's that PRISM acronym mentioned, problem, relevant info, success measures.
Exactly. It's a good checklist.
Yeah.
And for models focused on specific things like coding or maths, thinking about DeepSeek R1, again, giving it really accurate parameters for the problem.
Yeah.
It's just essential. Garbage in, garbage out, amplified.
And what about showing examples, this few-shot learning idea? How does that help with reasoning?
It's like teaching by example. If you want the model to break down a problem step by step using chain of thought,
right,
then showing it a couple of examples where you do exactly that. Here's the problem, here are the detailed steps, here's the answer that can dramatically improve its ability to follow that pattern on new problems. It learns the style of reasoning you want.
So you're essentially giving it a template for thinking.
In a way, yes. Implicit instruction through demonstration.
And we also need to be really specific about how we want the answer presented, the output format.
Yes, definitely. Tell it how to show its work. Numbered lists. Final answer first, then the steps. A table.
Why is that so important?
It just makes the output much easier to follow, especially if the reasoning is complex. It helps you, the user, understand and evaluate if the steps it took actually make sense.
Okay, let's get into some specific prompt patterns. Chain of thought, SOT, seems foundational. Can you break that down?
Sure. SOT is all about encouraging that step-by-step process before it gives the final answer. You often trigger it with simple phrases like, think step by step. Or, as we said, by providing few-shot examples that show that process.
And where is it most useful?
It's really effective for arithmetic, logical deduction puzzles, anything that needs multiple steps. The key thing is it makes the reasoning process viable, explicit. You can follow along.
Easier to check its homework, basically.
Pretty much. And some research suggests it works even better when the model has to deal with a lot of information, long contexts.
The material uses a classic logic puzzle, suspects A, B, and C, only one telling the truth. How would COT tackle that?
Right. A good COT prompt would guide the model. Step 1. Assume A is telling the truth. What follows? Does it contradict anything? Step 2. Assume B is telling the truth, and so on.
Systematically exploring the possibility.
Exactly. Laying out the implications step by step lets it eliminate contradictions and zero in on the consistent solution.
Interesting. What about the acting as pattern? Instructing the AI to take on a role.
Ah, yes, the role-playing prompt. This is clever because it taps into the vast knowledge the model already has from its training data.
How so?
By telling it, say, act as an experienced biologist or act as a logician, you're priming it.
Yeah.
You're encouraging it to use the vocabulary, the principles, the typical reasoning methods of that specific field or expert.
So it helps focus the model's knowledge.
Yes, exactly. It's great for simulating expert analysis or getting it to approach a problem from a specific disciplinary angle.
Makes sense. Then there's constraint-based prompting. This sounds crucial for logical tasks.
Absolutely crucial, especially when you need real rigor. You explicitly tell the model the rules of the game.
Like, only use deductive logic, or don't bring in outside facts.
Precisely. It forces the model to stick to a specific way of reasoning and prevents it from, making assumptions or pulling in information that wasn't provided. Essential for things like formal logic proofs or very controlled analysis.
We also saw the simple phrase, let's think step by step. How is that different from COT?
It's very similar in goal, but it's perhaps even more direct. Just a very explicit command. Show me your work. Methodically.
Useful for things like debugging or planning.
Exactly. Debugging code, outlining steps for a project, complex calculations, anywhere you need that clear, transparent, step-by-step breakdown for verification.
Now, self-consistency. Generating multiple reasoning paths.
Yeah.
That sounds computationally intensive, but potentially powerful.
It is. The idea is, for tricky or ambiguous problems where there might not be one single clear path, you get the model to try solving it several different ways.
Okay. And then
you look at the answers it came up with. The answer that appears most frequently across those different reasoning attempts is often the most robust or reliable one.
So it's like getting a second, third, and fourth opinion from the AI itself.
Kind of, yeah. It improves confidence in the answer, especially when the problem itself allows for multiple interpretations or assumptions.
And finally, integrating external tools. PAL, React. Letting the AI use calculators or code execution, that feels like a game changer.
It really is a major step. It lets the AI overcome some of its built-in limitations. LLMs aren't inherently great at precise math, for example.
Or knowing real-time information or executing formal logic perfectly.
Right. So by prompting them to use an external tool, then run some Python code for a calculation, query an API for current data, use a symbolic solver, you get the best of both worlds. The language understanding plus the precision of the tool.
And frameworks exist to help manage this interaction.
Yes. PL, programmated language models, and React, reasoning and acting, are frameworks designed for this. And we're even seeing specialized agents, like the ORLLM agent mentioned for operations research, which can automate complex tasks by orchestrating tool use.
The sources also mention even more advanced ideas briefly, like algorithm of thoughts and graph of thoughts. What are those about, quickly?
They're research frontiers, really, trying to build even more structure into the reasoning within the prompt itself. AOT might involve guiding the model through something like a search algorithm described in the prompt. Graph of thoughts represents reasoning as more of a network, allowing for more complex connections, backtracking, combining ideas in nonlinear ways. It's about exploring the solution space more systematically.
And you also mentioned prompts might need tailoring for RL-trained models.
Potentially, yes. If a model learns specific strategies during RL training, prompts that align with or trigger those learned strategies might be more effective.
And prompting for self-correction, getting it to review its own work.
That's becoming increasingly important. Explicitly asking a model, review your steps. Are there errors? Could there be another way? It encourages a kind of meta-reasoning, improving reliability.
It's clear that just checking the final answer isn't enough when evaluating these models. What are the key challenges here?
You're spot on. Evaluation has to look at the process. Are the steps logically sound? Is the reasoning consistent if you ask similar questions? That's crucial.
But it's hard. What are the main difficulties?
Well, hallucinations are still an issue. The model making up facts or steps that sound right but aren't. Maintaining logical consistency over really long chains of reasoning is tough.
They can lose the plot, basically.
Sometimes, yes. Generalization is another one, performing well on problems that look different from their training data. Bias from the training data can creep into the reasoning. Memory limitations in very long contexts.
And that deeper philosophical question.
Right, the debate about whether it's really reasoning or just incredibly sophisticated pattern matching. And the worry about alignment faking.
Meaning it looks like it's reasoning properly, but isn't really?
Exactly. It might just be generating the kind of output it knows we want to see, without genuine understanding or adherence to the logic. Evaluating that is tricky.
Despite these hurdles, the field is obviously moving incredibly fast. What trends are shaping the future here?
Well, definitely work on just building models with stronger reasoning built in from the start. Hybrid approaches are also big.
Combining neural nets with other techniques.
Yes, like symbolic AI, knowledge graphs, external tools, trying to get the best of different approaches. There's also a huge push on alignment.
Making sure the reasoning is ethical and matches human values.
Precisely. As they get better at reasoning, we need to ensure they reason well, in a broader sense. Scalability and efficiency are constant drivers too, making this power practical.
And supervising the process, not just the outcome.
Yes, process supervision training models based on the quality of their reasoning steps hold a lot of promise for building more reliable AI.
This has been fascinating. It really underscores how crucial mastering prompt engineering is now. It's not just a nice-to-have skill anymore, is it?
Not at all. For anyone working with these advanced models, especially in fields where the stakes are high medicine, finance, science, law, understanding how to communicate effectively, how to guide the reasoning, it's absolutely fundamental.
It's key to unlocking what they can do and doing it reliably.
Exactly. It's about building trust in these systems, which requires understanding how to interact with them at this deeper reasoning level.
So, thinking about everything we've discussed, the rapid progress, the persistent challenges, what breakthrough, maybe in model architecture or perhaps in prompting techniques, do you think might have the biggest impact in the next few years? Something for all of us watching this space to really think about.
That's the multi-billion-dollar question, isn't it? Lots to watch.
Indeed. Thanks so much for sharing your insights on this deep dive.
My pleasure.